Hey y'all, this is Mrs. James from Parkway High School, and I'm going to review Unit 4 with you. And we're going to start with Activity 19, which is all about those exponent rules. All right, so what we have here is a table of the 5 exponent rules that we want you to know in Algebra 1. So the first exponent rule that we have is what we call the product rule. And the product rule tells me that if I have like bases being multiplied together, I'm going to add my exponents together. All right, so for example, we have x squared times x to the 6th power. Well, I have like bases, x times x. Therefore, I'm going to add my exponents. So I'm going to simplify that to x to the 8th power. So simply add the exponents. Now the next rule that we have is the power rule. The power rule tells me that if I have an exponent raised to another exponent, all right, I'm going to multiply the two exponents in order to simplify them. So for example, we have 3x cubed to the 2nd power. All right. Now I also want you to notice that inside I have 3 times x cubed. So this exponent of 2 is going to both parts inside the parentheses. So that's going to give me 3 squared times x cubed to the 2nd power. And I just keep simplifying. Well, 3 squared is 9. And then I have a power to a power. And that tells me to multiply. So 3 times 2 is 6. So I have 9x to the 6th power. All right, let's look at the next one, which is the quotient rule. Well, the quotient rule tells me that if I have like bases being divided, I'm going to subtract my exponents. So for example, I have 45x to the 5th divided by 9x to the 3rd. Well, what is 45 divided by 9? That's 5. And then I have x to the 5th over x to the 3rd. 5 minus 3 is going to give me x squared. Now the next rule is probably one that can get a little confusing for some people, but it's really not bad at all. It is the negative exponent rule. All right? We don't want negative exponents. We like positive attitudes, therefore I want positive exponents. So I have x to the negative a. Well, anytime that I have a negative exponent, I want to move it to its reciprocal position and make that exponent positive. Okay? And I only want to move the base of the exponent and the exponent itself. So for example, I have 4 times x to the negative 2 power. Well, guys, I can rewrite that as 4 times x to the negative 2. So 4 is not the problem. It's that negative x to the negative 2 power that's the problem. So guys, I'm going to leave the 4 where it's at in the numerator, and that x to the negative 2 is going to come to the denominator, and it's going to become positive. So it's going to be 4 over x squared. All right. Now probably the easiest exponent rule there is the 0 exponent rule. And it tells me that anything to the 0 power is 1. Okay? So if I'm looking at this, we have 6 times x to the 0 power. Well, once again, I'm going to rewrite that as 6 times x to the 0 power. All right? So the 6 is going to remain the same. And then anything to the 0 power is 1. And then I just need to keep simplifying. What's 6 times 1? 6. Therefore, I've completely simplified that expression. All right? So now let's kind of combine some of these rules together. So for example number 1, we have 2x to the 5th times 5x to the 4th. Well, if we look at this problem, what rule from our table up top do you see? Well, the first rule that I see is the product rule. And according to the product rule, it tells me to add the exponents of like bases. So let's simplify. Well, let's just start with the coefficients. What's 2 times 5? 10. And I have x to the 5th times x to the 4th. Well, let's add the exponents. 5 plus 4 is 9. Therefore, my simplified answer is 10x to the 9th. Let's move on over to number 2. All right. So at first glance, what rule do you see happening here? Well, I see a numerator and denominator, so some division, therefore I'm thinking quotient rule. And the quotient rule tells me to subtract exponents of like bases. So let's start subtraction. Well, the 2 is just going to stay the same. Now I have x to the 5th and x. Well, we know that's an understood 1, exponent of 1. Therefore, I have x to the 5th over x to the 1st, and 5 minus 1 is x to the 4th. All right, now let's apply that same rule to my y's. Y to the 4th over y squared. 4 minus 2 is 2, therefore that's going to become y squared. Let's look at example number 3. Now when I first glance at this, I see negative exponent, but I also see the product rule as well. Now it is up to you which rule you want to apply first. That is your choice. I honestly prefer to do the product rule before I fix the negative exponent rule, just so I only have to move things once at the end. All right. So I'm going to apply the product rule first. So I have 2 times 5. It's going to give me 10. I have a squared times a to the understood exponent of 1. 2 plus 1 is 3. So I'm going to have a to the 3rd. And then I have b to the negative 3 times b to the understood 1. Negative 3 plus 1 is going to give me b to the negative 2 power. Okay, well, we have a negative exponent. And remember, we like things positive. Positive vibes only here. So I want positive exponents. And the negative exponent rule tells me to move it to the reciprocal position and make the exponent positive. So guys, from here, I'm going to leave the 10a cubed in the numerator. Nothing's wrong with that. But I'm going to take that b to the negative 2 power and move it to the denominator and make it positive. And last but not least, example number 4. Looking at this one, I see the power rule. I also see the quotient rule. And once again, it doesn't matter which one you want to apply first. That's your choice. I'm going to apply the power rule first. Okay, so that's going to give me 5 squared x squared y to the 8th over y to the 6th. Now I can apply that quotient rule, which is going to simplify to 5 squared is 25, x squared, and then y to the 8th over y to the 6th is going to give me y squared. All right, so the next 6 problems on the next page you do have is independent practice. So work through those. If you come across any questions, feel free to reach out to your teachers. I know they'll be happy to help. But thanks for joining me. I'll see you in the next activity.